Hello everyone. In this video lecture, we are going to see Module 4 concepts of operating system subject of 6th semester 17 CS 64 subject code. In the previous video lecture, we already seen about virtual memory management and file system implementation file system and implementation of file system concepts. Now here previous video lecture we completed about file system definition, file concept, access method, directory structure, also file system mounting, file sharing also completed in the previous video lecture. Today we are going to start with the protection till free space management we are going to see in this video lecture. We have to refer operating system principle 7th edition textbook for more information. We are seeing that file system implementation of file system concepts here. One of the topic is consistency semantic. This topic deals with the consistency between the views of a shared file on a networked system. When one user changes, see this line carefully, when one user changes the file, when do other users see the changes? That is the concept we have to see in consistent semantic. When one user changes the file, if any one of the user going to edit or create or delete or modify that file, then other user, if your access is there with the other user also, then other user when he can see that changes, that is concept we are going to see here. Now first method is Unix semantic. In this consistent semantic we have three methods. One is Unix semantic. What is that? A writer to an open file are immediately visible to any other user who has the file open. See, when one person going to edit one file, that file can shareable to another person also. That means second person also can see that file. But now first person going to edit something in that file. Now can that second person can see that? Yes, that is possible here. Writer, if that he can editing or he writing something, means it is visible to any other user who has the file open. That means if that second person also opened that file, so second person can see whatever he editing. That means whatever first person editing, right, that can see by second person also. So that is called Unix semantic. Immediately he can see that editing part. Session semantic. Write to an open file, that means second person can open that file, not immediately. He can't open that file. If first person going to edit that file, means second person can't open that file immediately. When file is closed, when he can see that when file is closed, then there is a changes, right? Yes. So now I will go for example. First person, he want to write or he want to edit something in that file. That file is accessed by second person also. Now consider first person is editing. Now second person can't see that changes because he can't open that file itself. When he can open that file? When first person editing is completed, right? Then only second person can open that file. Till that, for second person, that access is there, but open file is not possible. This is called session semantic. But unique semantic means whenever first person editing, right, second person also can see that editing. He can also open that, he can see that editing part. So that is called Unix. But session means once that editing part is completed, then only file can be opened by another person. This is called session semantic. Immutable shared file semantic. This is another different type. See this, under this system, when a file is declared as shared, that means when a file is declared as shared by its creator, that means user, then the name cannot be reused, that file name cannot be reused by any other process, that means any other person, and it cannot be modified, that file cannot be modified. Once that is shared by its creator, it is can't, that means we can't edit that, we can't use that name of the file also. This is called immutable shared file semantic. These are the three things of the consistent semantic. Another very important concept in the file management is protection. So how you are going to protect your file? The information in your computer system must be stored safely without any physical damage. That concept is called reliability. See this, reliability means what? If that system, computer system must stored safely without any physical damage, that is called reliability, and without and improper access, this is called protection. If there is any improper access, we have to go for protection. If there is any physical damage, then we have to go for reliability. That is the definition of reliability and protection. There is a difference. Okay, protection means if there is an improper access of that file, then we have to go for protection. If there is any physical damage of the file, then we have to go for reliability concept. Now protection is very important for the all files in a computer system. Now two types of methods are there in protection. One is a type of access and type access control. We will see that both one, type of access and access control, one by one. First one is a type of access. We could provide complete protection by the prohibiting access. Alternatively, we could provide free access with no protection. Two methods are there. Type of access means either we can give complete protection for that particular file by using prohibiting access, that means we can avoid all access by other persons. Okay. Another thing is we could provide free access with no protection. We are not using any protection, that file can be accessed by any person at any time. That is also possible. But which type we have to use, that is decided by user itself. Okay. Either we can give protection if user wants, or no protection means there is a file can be used by any person. Now here several different types of operation is there. One is a read. Either you can give, what is it, prohibiting access is there, right? Either read only possible, read the file, we can't write anything, only read is possible, or we can change access, only write access is possible, or we can change access to only execute access, only execution is possible at that time for that particular person. Only deleting is possible, delete option is we can give, that access we can give to one person. List option, list the names and attribute of the file, so that option we can give to another person. These are the type of access. We have type of access are read access, write access, execute access, delete access, list access. Now another matter is we are going to see is access control. This is related to protection. Second method, access control. See these lines carefully. To make access to the file depending on the identity of the user. Okay, depending on the identity of the user. Different user may need different types of access, right? Different user may need different types of access to a file or directory. different types of access needed by some of the persons or some of the user. So here the most general scheme to implement dependent access is to associate with each file and directory an access control list. Access control list, ACL. We have to use ACL concept. Specifying usernames, ACL contains usernames and the type of access allowed for each user. This is your main point in the access control. We are going to create one ACL, that is access control list, and inside that list we have usernames and what is the access given, type of access. What is the type of access means? We seen in the previous slide, read, write, execute, delete, list. We can give any one of the type or all the type access to that particular user, that is possible. So here each file we can give access to that particular user, but user name and type of the access we have to store in ACL, then only that is possible. When a user requests access to a particular file, when only once username is entered inside ACL, now user requests access to particular file, the operating system checks the access list. OS will check the ACL. At that time, if that user is listed for a requested access, then access is allowed. If that requested access is there in ACL, because ACL you are going to save what is the matter? One is username and type of access. If the type of access is given to user, then that is success. After checking operating system will check that yes, if it is true that access is given to user, means your file will open. Otherwise, protection violation occur and user job is denied access to file. Denied, you will get a denied option. Okay, in the screen you will get some error message. Okay, violation, protection violation, right? Because that access is not given to that particular user. That every access is given in ACL. Okay, ACL we need username and type of file access. So here, if we want to allow everyone to read a file, we must list all the user with the read access. This is one example. If we want to allow everyone to write a file, we must list all the user with write a file. Another option, if we want to allow everyone to read and write a file, we must list all user with the read and write access. This is about access control. Some other protection also there, that is about password, right? So password option is also there for protecting a file, but some disadvantage. What is the disadvantage? Number of password that a user needs to remember may be large. That is one thing. Another one password is used. Okay, if one password is used, then once your password is added or discovered, you got that password, means all the files can be accessed, right? Whatever file is there in directory, all files you can access. That is another problem. So these are the two disadvantages if you are going to add password. Okay. Now another system, that means structure we are going to see is file system structure. This is a very important question in your operating system. File system structure. Disk provide the bulk of secondary storage. Disk is a secondary device that will store your files, that you know that. Here we are going to see one layered approach for file system. What is that layer approach? You can see in this diagram. See, application program, first layer, second layer is logical file system, third layer is file organization module, fourth layer is basic file system, fifth is input output control, then sixth one is a device. Totally we have these much layers. This complete thing is called layered structure. We are using this layered structure for the file system management, that is file system structure. Okay, now all files are stored in secondary memory, that is called disk. How to store that, how to manage that thing we are seeing in file system structure. First we have application program. See, first layer is application program. That will give, that application program is the input for logical file system. Okay, application program, this one is the input for logic file system. Now logic file system will check your this application in your disk. Is that application is present in your disk or not? That is checked by logical file system. If that application program is present in your disk or secondary memory, then logical address of that application program will taken by logical file system and send that logical address to file organization module. Okay, file organization module will take that logical address from logical file system and converts that logical address to physical address. That physical address is sent to basic file system. Basic file system having main thing is there, we having some of the access, that is read file, write file, then delete file, create file. That access, that operation is there in basic file system. So here you are going to give, that is file organization module is output is your physical address. That physical address is sent to basic file system. Basic file system give one of the operation to that input output control. Input output control input is, here whatever input will given to input output control is, one is physical address, one is whatever the operation given by file system, basic file system. Operation may be read, write, delete, control, or list, like this many operations are there. So operation given by the basic file system to input output control, also the physical address also given to input output control. Two things is the input for input output control. Now input output control will control your device driver. You know the device driver. What is the device driver? That is a software part. For all the devices we have device controller. Okay, for these devices we have device controller. In order to control the device controller, we need one software, that is device drivers. So input output control will control your device drivers. That will inform the device drivers to do one operation. What is the operation? That is given by basic file system, right? Basic file system will give operation and physical address. Physical address anyway here we are getting, right? That physical address plus your operation is given to input output control. This will control your, or this will suggest your device driver to do that particular operation. That device driver will send that thing to devices to do that. Input output control will send it to device driver. Device driver will send that to devices to do that particular operation in the devices. So this thing is called file system structure. This is a layered structure. Just if you not understood this, just whatever I told, again replay that and study this thing. File system implementation is another concept in your file management. How to implement your file system. Okay, how to implement file system. There are two things. One is on disk structure, another one is in memory structure. What you mean by on disk structure? What do you mean by in memory structure? On disk structure means here it is completely related to your secondary devices or hard disk. On disk structure means it is a structure of the hard disk. In memory structure means it is a structure of the primary memory or main memory. Okay. On disk structure contain four things. One is a boot control block, volume control block, directory structure, file control block. Short form is FCB. In memory structure will contain that related thing about your main memory. Inside this we have four parts. One is a in memory mount table, in memory directory cache, system wide open file table, per process open file table. We will see this entire thing now. First one, on disk structure. On disk structure, I told in the previous slide itself, that is related to your secondary device, that is a hard disk. On disk, the file system may contain information about how to boot an operating system, the total number of blocks, number and location of free blocks, directory structure and individual file. In the secondary memory, you know that in the secondary memory we are going to store our files. Here on disk structure means here we are going to study some of the things. What are the things? What are the information we are going to see here? One, how to boot an operating system. That information here. Another one, how many number of blocks are there in your hard disk? You know, in the previous slide we are dividing secondary device or hard disk or disk into number of blocks. So total how many number of blocks are there, that we are going to see here. And number of location, how many number of locations are there, and how many free blocks are there. Okay, so anyway we are dividing the blocks, right? How many free blocks, how many filled blocks are there, every information we are going to see in the disk structure, that is a secondary device structure. In this we have some of the points. One is a boot control block. What is a boot control block? Contains information needed by the system. Just see this line, definitely you can understand this. Contain information needed by the system to boot an operating system from that volume. If that disk does not contain an operating system, this block is empty. So boot control block will use only if there is any operating system. If there is any operating system, then there is booting is required. Related to booting, we have some of the code, right? That code will managed by boot control block, that is there in secondary devices. Then next, volume control block. It contains volume details such as number of blocks present in your secondary device, size of the block, how many free blocks are there and their count, free block pointers, and free FCB and FCB pointer. This all information is there in your volume control block, and volume control block is there in your secondary device. Then directory structure. It contains a file name, you know directory, right? It contains file name and pointer to corresponding FCB. We are getting FCB term. What is that FCB? File control block. Okay. Directory structure contains file name and related informations. And last one, file control block, in short FCB. It contains details about ownership, size of a file, what are the permission given for that particular file, and date. Date means when you opened that file, when you closed that file, when you modified that file, when you created, deleted, everything details with the date is there in your file control block. So all information related to file, owner, size, permission is there in FCB. then file system and pointer to corresponding FCB, that is directory contain all the related information about file, and volume block contain your volumes, what is that, free block size, free block count, and number of partitions, how many number of blocks, every information is there in volume control block. Boot control block contain only boot code. Okay, boot code. If there is an operating system, then only we need boot code. Otherwise, operating system is not there, then this block is free. These are the things we have in secondary device. Then another we seen, what is that, in memory structure. This is related to your main memory. Okay, in memory means it is main memory. What is the structure contains in memory? Inside memory, in main memory, what is there? One is in memory mount table. Mount table is there. We already seen about mounting. It contains information about each mounted volume. Okay, mounted information is there in this. Then in memory directory cache. What is the directory cache means? Directory contain information about file, right? So recently accessed directory information is there in your cache. Recently accessed, but all the file information is there in directory structure, that we seen in the previous slide. See, directory structure, that is all the file information, but cache means we can say only a few things. That's why recently accessed files information is there in memory directory cache. Then system wide open file table. What do you mean by system wide open file table? Another one we have, per process open file table. Can you tell me what is the difference between these two? System wide open file table means it contains copy of the FCB for every currently open file. Now I will give one example for this both. Okay, now you opened 10 files in your system. In your computer you opened 10 files. All the 10 file related informations is there in system wide open file table. Anyway, open file table, what it contains, we seen in the previous video lecture. Open file table contains related information, that when you opened, who is the owner, what are the access things, everything, name of the file, size of the file, type of the file, all information is there in open file table. System wide open file table means in system how many process is open, that all file information is there in system wide open file table. Now what is a per process open file table? Here in your system, if 10 process is open means, 10 file are open means, here I am going for file. Okay, 10 files are open means all the 10 file information is there in system wide open file table, but currently you are working in which file, that information is there in per process open file table. Out of 10 you can't work with all the files, right? You can work only with one file. So you are opening 10 file, but you are working with only one file. So all the opened file information is there in system wide open file table, but which file you are working, that working file information is there in per process open file table. These are the things. I think you understood this concept. If you not understood, replay that video again and listen that properly. These are the informations we have in the in memory structure, or these are the tables actually. These are the blocks we have in main memory. See, in order to explain that previous slides, we have one diagram, neat diagram here given. See, open. Now listen this explanation. You want to open one file, then that request is sent to directory structure. Here that request is sent to directory structure. In the directory structure, that means in the secondary memory, which file you want to open, that file name is given, right? So that file name is searched in the directory structure. many it contains lot of blocks, right? Directory structure means the secondary memory we are dividing, right? So that contain lot of blocks. So in which block our file name is there? Okay, which block our file name is there, that we have to find out. Once that we got our file thing, or we got our file information, that means in this particular directory we have our file. Okay, we have 4 directory. In this particular directory we have the file name required by the user. So that file is sent to your memory, kernel memory. Okay, that is sent to your kernel memory. Kernel means the operating system. Okay, that is sent to your operating system part. Once that file came to operating system, then it checks for FCB. FCB means file control block. File control block contain all the information about that particular file. So you need that file in operating system, then only operating system will check your secondary storage, and it will collect all the information about that related file from the file control block. Okay, you want to open that file, so that file information is searched in this directory, then that file is sent to OS. OS will check all the information of that particular file with the file control block. This is the one concept. Another concept is here, that is a B. You want to read one file. Okay, you want to read one file. So how to read that file? So the read information or read request is sent to per process open file. Means you opened 10 files in your PC. Out of that you working with one file. You opened one file and you working with one file, but 9 files are working in background, right? Totally 10 you opened. Only you working now, presently working one, remaining 9 in background. It is already opened. So read will send a request to per process open file table. I told what do you mean per process open file table. There is a related information about that particular opened file. Okay, then that you know per process open file table and system wide open file table difference. Here we have only one file information is there, whichever open or working. All the file present in your PC, open file in your PC, that information is there in your system wide open file table. So anyway, out of these one of the process we opened, right? So that information is per process open file table. So you are reading that, then your request is sent to per process table. Per process table will send a request to system wide open file table. System wide open file table will send, that means the reading, right? That means the user want to read file. That's why this will, that is OS will ask file information of that particular file. File information from the file control block. Once that file control block will send that information, file information to OS, then that link, that means OS will search that particular file or from the data or data block from the secondary device. Once that secondary device got that file, then your reading file, so your reading is occur. So you are reading that file, user want to read that, so that request is sent to per process operation. That means that information is there in system wide also. That system wide will check that information about file with the secondary storage of file control block. File control block will send that information to OS. OS will send or OS will read that file information from the secondary device. So the reading is over. So these are the two operations given. One is open, one is the read. Directory implementation. This is another one. Directory implementation. Directory need to be fast to search, insert, delete with minimum of wasted disk space. So how to implement your directory? What is directory? It contain all the information about files. File you are going to store in secondary device. all the information about that files are there in, or how, where it is stored, and what is the size of the file, and that what is the file name, that information is there in your directory. So you have to implement that directory. There are two methods for implementing. One is linear list, one is hash table. We will see that one by one. First one is a linear list. Linear list is a directory implementation method. So how to implement directory? Linear manner. Linear manner. A linear list is the simplest and easiest directory structure to set up, but it does not have, it does have some drawbacks. So I will explain that in simple manner. Linear list means we have directory. That directory you want to search 100 totally. Now consider one directory is there. In that directory 100 file information is there. Files are stored in secondary device, but all the where it is stored, what is the size, what is the name, that information is there in directory. Now 100 information, 100 file information is there in your directory. Just assume. Out of that you need 90th, 90, that is a 90th your file information. You need 90th file information from the directory. So how to search that? Linear manner. So one by one, first one, second one, third one, like that your file information is checked. Once it reaches that 90th, then you got that file information, then you can access that remaining thing will happen. But linear manner we are going to search that. So disadvantage is linear list of directory is entries is that finding a file require a linear search. In order to find a file, you know that one by one, linear search means one by one search. So we can't jump to directly 90th. We have to go for 1, 2, 3 like that till 90. There is a lot of wastage of time is waste. Speed is also decreases, wastage of time. So to overcome this, software cache is implemented to store the recently accessed directory structure. So software cache, there is a one cache memory that will store whichever recently accessed files are there, right? So that information we are going to store in cache. So by that we can reduce that linear search option. Linear search, anyway linear list option method contain linear search, that will search one by one. So that will take a lot of time to go for 90th file, right? So that's why we can use cache memory. By that we can store whichever recently accessed, we can store there, because accessing your secondary memory is it will take lot of time, but accessing your cache is it takes very less time. That's why we are using cache memory that contain recently accessed file information. Second thing is hash table. So with this method, a linear list stores the directory entries, but hash data structure is also used. So there we seen one by one entry, that is a linear list, right? One by one entry. But here we are not going for one by one entry. Here we are using one method, that is a hash. We are going to apply hash method on that file. The hash table take a value computed from the file name and return a pointer to the file name in this linear list. Therefore, it can greatly decreases the directory search time. Okay, we can reduce the time. One of the disadvantages is collision. There may be a chance of collision. What do you mean by collision? Here we have situation where two file name hash to the same location. There is a chance of getting two file name hash to a same location. Okay, same location, there is two files may be saved, or there is a chance of collision. Okay, so but what is the advantage? Time, search time will decrease. Okay, in order to avoid collision, we have another method, that is a chained overflow method. What is that chained overflow? See, chained overflow method, each hash entry can be linked list instead of individual value. So one by one search, that is called linear list, but hash table we have linked list concept. So what is that linked list concept? We will see that in coming slides. We have another very important concept in your module 4, that is a file system module, is allocation methods. How to allocate your file, that method. So how to allocate your space for the file, okay, that is called allocation method. In the secondary memory we have blocks, a lot of blocks. How to allocate that blocks to your file? You want to save your file means how to allocate that blocks memory to your file. That concept is called allocation methods. We will see that we have three methods. One is contiguous allocation, linked allocation, and index allocation. We will see that one by one. First one is a contiguous allocation. What do you mean by contiguous allocation? Here, contiguous allocation requires that all blocks of the file be kept together contiguously. I will explain with the example. See, this is your secondary memory. This is your secondary memory. It contains lot of blocks. We are dividing that secondary memory in blocks for storing your files. So we have here 31, that is 0 to 30, 32 blocks are there here. We divided the secondary memory into 32 blocks. Now here we have directory table, okay. Here count file, your count is the file name. That file name starting is 0 and its size is 2. So meaning of this is we are going to create directory. This is a directory, okay. How to create directory that contain all the information about file. So first you have one file count, you want to store that. So before creating directory, I will tell you how to store this. So we have 32 blocks, right? You want to store count file, so you will store that. So count file is big, so you need two blocks, one here, one here. Combinedly we have one file that is called count file. Count file is stored in these two blocks, okay. Now thing is, what do you mean by contiguous? We have to store this one, that is a count file, in one is here, one is here, okay. Immediately next we have to store, but maybe file size is less, then block size is fixed already. Initially block size is fixed. If file size is small, then it will cover small portion of the block, right? So now I will consider here block size. One block size is 10, okay. Here one block size is 10, another block size is 10. So 20 is the block size for these two. Now consider count size is 18. Count size is 18. So it will divide, 10 is stored here because this size of the block is 10, right? So out of count file size is 18, right? Out of that 10 is stored here because size of this also 10, count file size is 10 is stored here. Remaining, this size is 10, but count file remaining is only 8, right? Because 18 is the total size of the count, 8 is remaining. That 8 we are going to store in this block. So totally here 10, here 8, 18 is the count. But here 10 is the size of the block, we stored only 8. What is the remaining part? 2. 2 is remaining, that is memory is wasted. 2, that is a 2, I am not mentioning any units for that. 8 is booked, but that 2 space is there, right? That is free. Because of that, there is a chance of external and internal fragmentations. that we know that what do you mean by fragmentation concept in the module, that is a previous module. So here we are getting chance that because of this contiguous block there is a chance of internal and external fragmentation. That means there is a chance of wasting a memory, there is a chance of wasting your block size, okay, wasting your block memory. So that's why we have to avoid this contiguous allocation. I will repeat that. Count, what is the starting address? See, starting block number is 2. What is the size of the block? 2. So it cover this block and this block. What is the next block? 2, right? So length is 2. So 0 and 1, it covers 2 block. That's why length is 2. That is a directory. And second, TR is the file name. Where it start? 14. See here, where is, here we have 14. So in the 14 it starts. And what is the length of the file? TR 3. So that file will cover 3 blocks. One is 14, one is 15, one is 16. So that will cover, that TR file will cover 3 blocks. Like that, anywhere we can store our files. But in the directory, file name is there, which block it is started, and what is the size of the your file, how many blocks it takes to store your file. That information also needed in the directory. So this method is called contiguous allocation. Contiguous means again we are storing that in continuous manner. Another one, we block size is already fixed, but file size may vary. There is a chance of wasting of memory. Okay. So in order to avoid that, we are going for another concept called linked allocation. So what do you mean by linked? Disk file can be stored as a linked list with the expense of storage space consumed by each link. Linked allocation involves no external fragmentation. In the previous, we had external and internal fragmentation. In order to avoid that, we have linked allocation. Here, no external fragmentation, does not require pre-known file size, and allow files to grow dynamically at any time. Here we don't have any disadvantage. That means previous disadvantage is avoided here. Unfortunately, linked allocation is only efficient for sequential access files, as random access requires starting at the beginning of the list for each newer location access. Another big problem with the linked allocation is reliability. If pointer is lost or damaged, if any pointer or list is damaged, there is a chance of, that is a reliability concept that is completely vanished. So I will tell you the concept with the one diagram. See this diagram. Here we have secondary memory. These secondary memory are divided and we have blocks. The block size is fixed. Okay. Here totally 32 blocks are there. 32 blocks are there. Now, what is the concept of linked list means? You have one file that is called zip. Okay, zip is one file name. That starting address is 9. Okay, starting block number is 9. What is the size of the file? 25. Sorry. This is the end block. Start block is 9, end block is 25. So it block start with 9, end with 25. Till that we are going to store our file. So see, start from 9. So where is 9? 9 is here. See, 9 is here. Your file, we don't know what is the file size. So your zip file will divided into small blocks, and one block is stored in here. Okay, another block where it's stored, it will goes to here, this one. Which one? 16. From 9 to 16. So why you are moving 9 to 16? There is no condition that you have to store continuously. You can store anywhere. related to that zip file, whatever we have blocks, that block we can store anywhere in the secondary memory. So here one of the small part we stored in 9, then it is next part of that file is stored in 16. So how to know from 9 to 16? We have to jump that in the 9th block with the file information we have to store 16th block address also. That means after 9 that file information is there in 16th block. So 16th block address also stored in 9th block. Then from another part is stored in 16th, right? So another part is there in file. So that file is stored in which block? That is stored in first block. That is stored in first block. Okay. So how to store that? Here in the 16, one of the part of the file is stored, right? Like that, we have to store another information in the 16th block. What is that? First block address is stored in 16th block. With the file information, we have to store address of the next block also. By that, that file is the information is there in first. So here first block we have to store with the file information, we have to store address of the next block where we have to jump. That address also we have to store in first block. So another is 2, from 2 to 25. Okay, so 25 is the last block because that much big zip file is big file. So when you are going to store that in blocks, anyway block size is already fixed, right? So here we are going to store small information, some information in 1, then we are jumping into 16. So first block contain information about file information plus information about next block also. So here we have another file information, some information plus address of the next block, like this we have to continue. So starting from 9, so here starting from 9 that will continue 16, 1, then 10, then 25. So it is in the directory we have to mention, for the linked list concept in the directory we have to mention what is the start block and what is the end block, but that is not there in your previous contiguous. Here what is the start block and what is the length, because we are storing in continuous fashion. Here a random fashion we are storing, that's why start block and end block we have to store. So we have to connect that block with address. Each block contain file information also, each block contain file information plus address of the next block where file information stored. Like this we have to go for linked list concept. But see the directory structure, this is the directory structure, start, end. Now index allocation. What do you mean by index allocation? Index allocation means we have, index page, right? In the book we have index page that contain all the information about your test book. So that which page your concept is there, which page you have that topic, that thing is there in your index page, all information like that. Here you have to maintain one index page or index. Index allocation combines all the index or block numbers. We are telling about block numbers because for each accessing file into common block. See, I will explain in the simple manner. I will show the previous slide here. See this is a linked list concept, but in the index page concept, here no need to link. That means no need to store address of the next block. Take first block. If you are considering 9th block, start with 9. Okay, 9. Then 9 itself contain file information plus you can store that other file, that means same file information, small amount we can store in 9, remaining amount we can store anywhere else, but wherever we are going to store, right, that file block number we have to mention in first block. If you are starting with the 9 means 9 contain file information plus all the block information, means index page is there in 9th block itself. So in the index page we will get where is the data related to file in other block, that you will get in the 9th page itself, 9th block itself. Okay, so index page plus file information we are going to store in 9. So index page contains all the other block which stores that corresponding file information. That block number is there in index page. So easily, no need to link between that blocks. Here this is in linked list concept. Here we have to link. There no need to link anything. Just in first block itself we are maintaining one index page. That index page contain all the other block informations. So no linking is required. This is called index allocation. Now another concept, that is a very important concept, free space management. We have hard disk, that is a secondary device. So how to manage if there is any free blocks are there, how to manage that free blocks, that concept we are going to see in free space management. So the space created after deleting the file can be reused. You know that once that file is deleted from the secondary device or that from some space, we can reuse that file, we can reuse that block. How to reuse? Another important aspect of disk management is keeping track of free space in memory. That is another very important, free space, tracking of free space. The list which keeps track of free space in memory is called free space list. It is a list, free space list is a list which contain all the free space information, free space block information. To create a file, search the free space list for the required amount of space and allocate the space to the new file. I think you can understand these lines, no need to explain in detail. To create a file, search the free space list for the required amount, because all the free space blocks are there in free space list. So you can search whichever you want, then store your file in that block. The space is then removed from this free frame list. So why? So here now we are moving our file. Yes, I will just repeat that. This space is then removed from the free space list. So once that free space list we considered means some of the blocks which are free, that we going to consider in a free space list. When you want to load one file in that memory, so take whichever you want block from the free space list, store that file in that block. Then once you store that file in that block number you have to remove from the free space list, because that is full, right? That's why we have to remove from the free space list. That is, the space is the removed from the free space list. When a file is deleted, its disk space is added to the free space list. Okay, the file space list is implemented in different way. So free space management, we have different methods: bit vector, linked list, grouping and counting. We will see that one by one. First one is a bit vector. So what do you mean by bit vector? With one line we can explain that. It is a bit vector in which each bit represent a disk block. Each bit will represent disk block. Set to 1. Bit vector you have to set to 1 if free. If your block is free, then your bit will 1, or that bit is 0 if that block is allocated. That means if that block is full, bit is 0. If that block is free, bit is 1. That is the concept of bit vector. You can see this, they given here one example. Consider this disk where block 2, 3, 4, 5 like this. These are the numbers are free. These blocks are free and remaining blocks are allocated. How to write the bit vector? So here we can write, see, 0, start from 0. 0 it is booked, right? So it is already allocated. 0 it is, only these are free now. Only these are free. So 0, starting from 0. 0 it is booked. 1 is, it is booked. But 2 they given here free, right? So 1. 3, 1 here free. 4 free, right? So 1. Whichever free, go for 1. Whichever allocated, go for 0. That is the concept of bit vector. It is actually very efficient manner, okay, in order to find out that free space. Second one is a linked list. So we are getting a linked list concept again here. So you know that linked list means we are linking that block numbers. Okay. So starting from here, you can see only diagram here. See, 2 is free. So whatever white color we are seeing here, that all are allocated and remaining thing is free. So 2 it is free. In the 2 we have one address. Whichever block is free next, that address is there here itself. So 3 is free. So 3 address we have to store in 2. Then 3. Jump it to 3. So 3, from 3 where we have to jump? 4, right? So 4 address is stored in 3. So 4 also free. Then from 3 you have to jump it to 4. 4 it is free, and this address, inside this block we have to store next free block address. Which is the next free block address? 5. That address we have to store in 4. So that means we have to link that. Then we have to jump there, means here also we have whichever free block next, that address we have in 5. So 8th address is there in 5. So you have to link that. So this concept is called linked list. A linked list can also be used to keep track of all free blocks. Just to keep track of all free blocks. Another method is grouping. So grouping is another very easy method, a variation on linked list, free list. Okay. It stores, this is very important definition, it stores the address of n free blocks in the first free block. Only this line is enough to understand grouping. Here previous linked list we seen, we are going to link whichever free, that block address we are going to store in the previous, right? But in the grouping method, here we have 2, right? 2 block, that is free. Remaining, which are all the free blocks, all the free block address is collected and stored in second block. I think you understood. Here we are going to link in the grouping concept, no need to link. In the second block itself, we are going to store all the free block list. Whichever free blocks, that address we are going to store in first block itself. That is called grouping. Okay. Last one is a counting. When there are multiple contiguous block of free space, then the system can keep track of starting address of the group and number of contiguous free blocks. So in the previous grouping concept, what we seen, in the first block itself we are going to store all the address of the next free blocks. That is called grouping. But what is the counting? Counting means in the first block we are going to store how many blocks are there, free blocks in the next. Okay, only count we are going to give, no need to store address. In the counting concept, how many blocks are free in the next, that means next how many blocks are free, that all count we have to place in first block. That block, that concept is called counting. So these are the very important file concept or file management system concepts. Thank you.